So the first thing, the question is, did you study the sequential circuit? All of you, you know it?
Yes.
يا شباب معي؟
Yes.
Yes,
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 Professor,
the
please carry on.
registers and relatches.
Yes, yes. خليكم معي عشان نخلص المحاضرة بسرعة كل ما أسأل. Okay, so sequential circuit, you know that there is something called combinational circuit and then there is something called sequential, like a system or a circuit. So two types. Combinational, what we have took so far, they are combinational circuits. And now this one is a sequential circuit. So how to know the difference between them? The sequential like has a memory, like in general, if there is some memory, that's a sequential circuit. And something is running from a clock, like we have a clock signal that makes something tick, so we know it's a sequential circuit. And also sequential has something like memory registers or whatever, we know it's a sequential circuit. So today's experiment is about sequential. We have some modules. We need to write a code for it. So the first thing, we'll write a code for something called register. I think all of you know what's a register mean. It's like the basic type of memory. تخزن فيه, just save whatever number of bits on a register. So before we start with the register, we have to understand what's the D flip-flop. So my question is, all of you, do you still remember the D flip-flop?
Yes.
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 Yeah.
Yes.
Yes. Yes. Okay, so just to fresh your memory, do you know what's this small circuit here in the set and clear? Do you know what does it mean? Nobody? Nobody? The small circle here in the set and clear, do you know what does it mean, this one?
Inverted.
Clear is inverted.
Inverted signal. So normally one is on, like turn on, and zero is off. But if you see some inverted signal like this, you know it's inverted. Means zero is on and one is off. Just beware of that. So now let's study the D flip-flop. Just make a quick review. So the first thing in the D flip-flop, you have to see the priority, the highest one. You see the control signals. We have a set or preset. It has two names, and then we have a clear. So first you have to see both of them, because if one is enabled, it will be applicable in the output, the highest priority. So let's see. If the preset is 0, which means on, and the clear is 1, which means off. So you will ignore everything. I ignore the clock and I ignore the D, the input. We have a D input. So we ignore them. X means don't care. And let's see, the Q will be 1 and the Q bar will be 0. These are the outputs. So, and then if we have a clear 0, so the clear is on. So which means that the output will be 0 and the inverted will be 1. Very easy to understand. And then if both are on, which normally no one do it, but just like if you make confusion, making the preset is on and the clear is on, uh, nobody do it. But what will happen? It just toggles very fast. Like a Q will be 1 and 0, 1, 0, 1, 0, and same thing for the Q bar, 1, 0, 1, 0. So when you see it, it's like 1, 1. It's like they all are 1. So nobody used that. Okay, now let's see the options that we don't have any control signal. They both are off. There is no preset, there is no clear. So which means that we follow the normal D flip-flop. So let's see, nothing here, 1, 1, 1, 1. So let's see, it depends on the positive edge of the clock. All of you, you know what does it mean, positive edge of the clock?
The rising
Yes.
edge.
The
It will
rising. So
go
we know
forward.
the clock signal is like this. So when it's going 0 and then it's going up to 1, that's the positive edge. Only this small area, when it's going from changing from 0 to 1, we call this positive edge. Only a small area of time. So at the positive edge of the clock, you see the input D. If it's 0, the output will just copy that 0, and then the bar will be the inverted. And the same thing, again, in the positive edge, if we have a D as a 1, the output will be the same 1, and the bar will be the inverted of it. So now if there is no positive edge, like you are in another area of the clock, or maybe the clock is turned off, whatever. So what will happen? You don't care about the input D, and the output will be no change. So what does it mean? No change. Anyone can tell me?
It stays at as the value it was before.
Yes, Ali Hamad معي?
Yes.
Yes. Okay, so no change means that it will stay as the last value. It will stay, nothing will change. So when you see like this, you know there is something here. I can save one single bit using the D flip-flop. I can put something on my input D, give it a positive edge, and then it will be saved on the queue. And then you turn off the clock or make it zero, whatever, and then your value is there on the D flip-flop. So I have the ability using a single flip-flop to save a single bit. So of course single bit is not enough. I can memorize it or whatever, and it's not enough. So we create something called a register after that. So a register is like arrays of D flip-flops. Like if I want to save an 8-bit, you just have 8 D flip-flops, and if you want to save 16-bit, I need to have 16 flip-flops. So let's continue on with the manual, and then it says about JK flip-flops. We'll not take it, but if you want to memorize or like review what you have took so far, it's a similar thing, but instead you see JK, it will be Q and Q bar. You see JK will be Q and Q bar, like the same thing is copied. Very easy to understand. Now, let's understand the register. Like, okay, I know it's an array of D flip-flops, like 1, 2, 3, 4, assuming it's a 4-bit. So the connection between them, how does it look like, the connection between them? So here, it doesn't state. So I will tell you now how the connection works. So let's see here. We'll take all of it. So let's start with the register. And then let's see the first picture. And then let's minimize myself a little bit. Okay, so assuming that you have a number of bits. So we say we have the same number of D flip-flops to be saved. So that's the first one, the second one, and that's the last one. So we arrange them together. So the first thing we have to sacrifice, okay, you see we have a Q and a Q bar. So there is no need to take both of them. It doesn't make sense. So we just take the Q and the Q bar, we leave it not connected. Okay, that's the first thing we have to understand. Yani, we don't need many signals. We just need Q only. So the second step, we separate the bits. So assuming you have multiple bits like a 16-bit or 8-bit, you divide the number of bits for each flip-flop. Like that's the first bit, it's going to the first D flip-flop. The second bit is going to the second flip-flop. And so on to the last bit is going to the last flip-flop. So same thing from reading the memory. When you read what's saved on the memory, you read the outputs from the D flip-flops. You see, that's the first bit, the second bit, and then the last bit. You just divide each one to each D flip-flop. Now, the next step, you see, the set signal. So normally we have a set signal and the clear signal to make the outputs either 1 or 0 for all of them. So there is no need to have two control signals. I can disable one of them and then I have the ability to control the other. You see, we have to minimize the number of signals. So I will disable the set. So I connected all the set signal together and I want to disable it. So now the question, Hatem, معي?
Yes, doctor.
Yes, should I connect it to what? All the set signal. I want to disable it.
So it doesn't have any function?
Yes, I want to disable. Should I connect like to 0 or to 1?
No, to 1.
To 1. Yes. So I need to connect it to 1. 1 means disable. You see, it's inverted. You have to be careful. So I need to connect it to 1, which means like the power source, the voltage, like 5 volt or 3.3 volt. It depends with the system. You just connect it and you just relax. Okay, there is no set signal whatsoever. Now, let's see the clear signal. What should we do with it? So, of course, the clock signal, sorry. So, the clock signal. You see, you know the triangle here, that's the clock for each one of the D flip-flop. So, of course, I will connect all of them to the master clock of the system. So you know each system has a master clock, like in your phone, mobile phone, it says gigahertz, like the speed of the CPU is this gigahertz. So that's the master clock for everything. Same thing with the PC, same thing with whatever system, it has a master clock. So of course you'll connect all of them to the clock because it's a sequential circuit, so everything should works with a clock. Now, the next thing, the clear signal. So of course, all the clear signal will be connected to one input signal. It's called clear, whatever the name. So which means that you have the ability, like I want to format the memory, clear the content of the memory. So you just send that clear signal to be one. You see, I remove the circle just to be convenient for all of us. So I just remove the circle now. So the clear signal, if I say one, it will format the memory. So all the outputs will be 0. So now I have the ability to have some format to the memory. Okay, next step. Okay, before we start. So I think, do you think it's complete now? Here. تفضل الله معي.
معك يا دكتور.
So do you think it's complete now? Is it a complete register or that we are missing something?
I think it's complete, yes.
You think it's complete. طيب الحميداني. معي عبد العزيز. So غائب. Okay, حسن شويش معي.
معك يا دكتور.
Okay, so you see, like there is nothing wrong. So I did the connection. So now I have the ability to clear the memory. Now let's see, assuming you create a register like this one, there is something wrong here. So there is something wrong. So let's see, you turn on the system and that's the register in the system. And now the clock is running. So what will happen? The clock is running. So then at the positive edge of the clock, you know, the output Q will be the same as the input. So the memory has been written. And then there is another positive edge and it's been written again. Another clock, it's been written again. You see what's going on? All of you?
I don't understand.
Doctor,
Yes.
I don't understand it.
You don't understand. So you know the clock is running all the time because that's the master clock. It's running all the time. And you know the Q will be equal to D at the positive edge of the clock, right?
Yes, at the rising edge.
Yes, at the rising edge. And the clock is running all the time. So assuming that you have prepared something on the input D, and then it has been saved. And then it has been saved again. And then it has been saved again. You change the value of D to for whatever something else, and the register is writing all the time. Is writing all the time, you see? Do you know what's going on?
Doctor, shouldn't Q0 be connected to D1?
Which one?
Q0. The output
Connected.
of the
Yes, connected to what?
connected to D1?
No, why? No. No, nothing like that. Don't think like that. That's the memory. It's like this. ايش الفائدة لو اعمل connect? Why? It doesn't make sense.
Yeah.
Okay, so please يعني understand. Hamza, do you understand what's going on?
It's not being saved.
Yes, you see, it's saving all the time. You cannot control it. It's saving all the time. At the positive edge, it's been saving. At the positive edge, it's been saving. You cannot control it. Like, stop. I want to stop. I prepared the input D and it has been saved. I want to stop it because that's it. I don't want to save anymore. Like, I want to protect my content, but you see the clock is running all the time. It's been saving and saving and saving. So we don't have the ability to control the memory. Do you see what's going on here? So
Yes.
now, how to fix it? Hassan and Muslim, how to fix it?
I think we should connect some circuitry around the register.
Yes, we need to have some external circuit, yes. So if someone says, I can disable the clock, you cannot, because the clock is running all the time. You need, that's the master clock for the whole system. It's running all the time. If you turn it off, everything will turn off. Like assuming the phone, if you want to turn off for the register, for the sake of the register, to keep the memory, you see the display is off and everything is off. You cannot do it. So what's the workaround with it? You can do something like this. So now focus on the left side. What's going on? It's like this. So if I just make another AND gate here, and then you put the clock at the input of the AND, and then the other input of the AND, I make a signal from my side. So that's a load signal. So you see, I didn't change anything with the clock. It's running all the time. So now, if the load is 1, so I'm saying the load is 1, what will happen? The output of the AND,
It will be one if the clock is
it will
one.
be connected to the clock.
yes, it will be the clock. So you see, if the load is 1, the output will depend on the clock. It will be the same thing. The clock will go into the output, and your register is running. Now it's been saving. And you want to stop. Okay, that's it. I don't want to save. That's it. I saved my value. I want to stop. So I make the load signal 0. So if the load signal is 0, what will happen to the output of the AND?
0.
All the
Zero.
time 0.
0.
Yes, all the time 0. So there is no positive edge. So your memory, you see, it's protected. So now I have the ability when to save. Of course, like whatever you program, you work, there's ability to save or not save. So it's like this. So you give a positive edge, it's saved, and then you turn it off. And still the clock is running all the time. You see, we didn't change anything. So now that's the complete register circuit. So you know, all of us know how to connect the register circuit. You just arrange the D flip-flops and do the connection like this. And then don't forget, you have to have some control here, when to save and when not to save. And of course, you want to clear if you want. That's it. So now let's create a code for this one. So to understand what's going on in the register, you may have a truth table like this. So now let's see the truth table now for the whole register. If the clear is 1, of course, we don't care about all of these because the output will be all the time 0. That's the clear signal. And now if there is no clear signal 0, 0, it depends on the positive edge of the clock. If the load now is 1, we write the value D to the Q. So the Q will be equal D. If there is no load signal, the Q will be remain the last one, like no change. The Q will be equal to the Q. So understanding this, we can write a code for this one. So now I will run the active.html and let's write a code for this one because online simulation and all that stuff. So when you run the program, let's see it's running. And we cannot implement because it's online, but I did the implementation with FPGA. I have a video of that. So when you finish everything, I will open the video and let's see what will happen to the FPGA. But first, let's do some simulation. So now, of course, in your case, maybe you want to work with the same workspace, or maybe you want to create another one. So in my case, I want to create another one. Why not? So experiment 4 whatsoever, and then empty design, and it's a Verilog, and then let's call it whatever project, any name. Finished. Don't forget, you go to the design settings, and then you have simulation Verilog. You have to disable Verilog optimization. Apply. Okay. Now, Abdulaziz Ismail, right?
Yes.
Yes. Okay. So we need to create a Verilog source, of course, to write the program. So next, what should we call it? It's a register, so we'll create a code for the register. So you may say it register. So this one is okay, but don't say reg. So can someone know why we cannot say reg for the name of the module?
Because reg is a keyword.
Yes,
Deadlock.
because yes, Hatem. Okay, because reg is a command, is already a command for the Verilog, so you cannot say like this. So be careful. Register with an R capital, so I am guaranteed that it's not a command. And then finish. So that's the code. Let's write it.
Doctor,
Yes?
Can you repeat how did you disable Verilog optimization?
Design, settings, under simulation, Verilog, here, Verilog optimization, you have to disable it. That's the
Thank you.
second time. Now, for the module of the register, of course, you need to know which are the inputs, which are the outputs. So we know that we have a clock, we have a clear, we have a load, we have an input D, and then we have the output Q. So we list all of them there. So we have a clock, and why not? I want it small. So we have a clock, we have a load signal, we have a clear signal, and then we have what we call it, Q, and then we have D. I think that's all three of them. And now the next step, we have to define which one is input. So of course the
After
clock.
The spelling of load.
Yes.
The spelling of load is wrong.
The spelling of the module.
Load.
Load. Yes. Yes, load. It's just a name, okay? So yes, yeah, maybe you're right. So the inputs, of course, the clock is an input, and load is an input, and then clear also is an input. But D, yes, it's an input, but multiple bits. So you write another command for the input for, let's say I want to make a 4-bit register. So of course the input D will be 4-bit and the output Q will be 4-bit. And then the output, and I will use always command, so I know output reg 3-bit for the Q. I think we prepare everything. So there is a way we can write the code using the circuit itself. You create something called D flip-flops, and then you call it and do the connection. That's taking a long time. We'll not do it. So we understand what's going on. So we can describe it using if else. So let's say always at. So we write something here. Always at what? You know what I told you before? Always at
Star.
Or
yes, star. So normally we used star, but the information here, we don't use star in sequential circuit. We use star for the combinational circuit. You know, all the circuits we took so far, they are combinational circuits, like a normal circuit, nothing special to it. But when you have something called clock in whatever module, you cannot say star here. Okay, so you cannot do it. That's not sequential now, but that's a sequential element. The register is a sequential element. So what should I write for the always at? I know the sequential circuits, they only works at the positive edge of the clock. So the always command should only work at the positive edge of the clock. So you say positive edge of the clock. So how to do it? You say POS for the positive edge, and then you just say edge. Combine post edge, and then the positive edge of what? For the clock. Don't forget, every sequential element module that has a clock, you have to say positive edge of the clock. Don't say star for only like a normal circuit, whatever other circuits. Just remember that. And then begin. I wrote wrong. Begin. Now here we just do if and else. So the first thing we check is what? For the register, do I check the input D, or do I check the input load, or do I check the input clear? So which one should I check first?
Clear.
The load.
Clear. Yes, we have load and clear. Okay, so which one? I hear load and I hear clear. So which one is most important?
Clear.
Clear. Yes, clear signal is the most important one because it's the master for the D flip-flop. You know, we say we first check the preset and clear, and then you check the positive edge and the load and the other stuff. So the first thing you check if the clear signal is 1 or not. So you say if, and then you open a bracket, clear is equal 1. It's not inverted. I removed the circle. So if the clear is 1, we format the memory. So what's the output will be? What's the execution now?
Q is 0.
Q equals 0.
Q equals 0. That's it. Yes, Q is equal 0. So I have an information here, so be careful. We normally use that. Yes, Q is equal 0. That's the meaning. But I cannot say it like this because I am using positive edge of the clock. So when you say positive edge of the clock, or like in general, if you work with a sequential element, so you know positive edge of the clock, it's mentioned here. So you have to forget about the equal, symbol equal like this one. You have to say like this. It's not less and it's not less than, it's an equal, but it's supposed to be like that. This equal for the sequential circuit. Okay, it's an equal, so just don't get confused. It's an equal, but only used for the sequential circuit. So please be careful. If there is a positive edge, you have to write equal like this. Okay, any questions so far? It's mentioned in the manual also. So if you remember, maybe you took it before. This one is called non-blocking assignment. Do you still remember that non-blocking assignment?
Yes.
Yes.
Yes, I do.
Yes, so that's we call non-blocking assignments we use for the sequential. If there's a positive edge, every assignment, it has to be non-blocking. Okay, so let's continue on. It's equal to 0. Q is equal to 0. Now, we finish with the clear signal. So we say else if. So next thing, we check what? After the clear, we check what? Hadi?
Yes. If
We check what?
the clear equal to 0,
If the clear is equal to 0.
the Q will be equal to 1.
No. ملخبط يا هادي، ايش فيك معي انت ولا لا؟ Okay.
معك.
So if clear is equal to 1, we format the memory. Else if خلاص, we finish with the we finish with the clear. So we check what next? الوليد?
Yes, the load.
The load signal. خلاص. This here the clear is 0. We know that. So else if the load is 1. Now we have a load signal. And the clear is 0 here. So what will happen? Sami, what will happen?
We allow the new input, which is D.
Yes, the Q will be equal to the input D. So we write the memory. Yes, so we write the memory. So now Q is equal D, the non-blocking assignment. Beware. So we write to the memory. Q is equal D. That's the input D. And then, if there is nothing else, what should we do? Abdullah, Luhebi?
Q won't change.
Q won't change. So how to say here?
Q equal Q, maybe.
Yes, Q is equal Q. Now, I think the code is finished now. So now let me ask you, is that line important, the last two lines?
No, we can delete it.
I don't think so.
Yes, it's not important. We can delete it. But you see, of course, if there is no load signal, nothing happens. So the Q should retain the same old value. So what's the point of writing this? What's the point? If you get what I mean, what's the point? So, Abdulaziz, Abdul Sabur, mine?
Yes, doctor.
Yes, okay. So what's the point here? It's like we call it refresh. Okay, so the value of the Q, we just refresh it again using that line. So what's the importance of the refresh? So you know that's a memory, register a memory. So assuming you saved something to the memory and then you leave it for a long period of time. So you know the saving in the D flip-flop, it's like there is a charge on the Q. So normally the charge will disappear over time. So how to refresh it? We have to say refresh here. Okay, so we say Q is equal to the Q, like we just renew the charge again, like the 0 will be 0 and the 1 will be 1. Okay, so we call it refresh because we need to save the charge. If you want, of course, if you want or not. but just an advanced thing. You know, there's something called a refresh circuit for whatever component in the memory, just to do some refreshing. Okay, so in coding, it's like this. So of course we don't need it because we have a symbol register on the FPGA, everything is protected. So normally we don't use it, but we included here just for all of us to understand what is the refresh circuit for the element. Okay, all of us, you should understand. So that's an advanced okay information for you now, but we'll keep it because in the manual it kept it, we'll keep it, but all of us know what's going on there. So now I think the code is ready. That's everything. Are there anything missing here? Are there
and
anything missing?
begin
Yes?
and begin.
Yes, the begin and end. So you see, I said begin in the top, so I need to say end to close it. And then I think that's it. So let's compile it. Design, compile, and yes, no error, no warning. Okay, so when you go to the manual, you see the code is the same thing, but it had added something on the always add. So let me ask you a question. In sequential circuits, you know there is two types. Can someone tell me? Hassan, Shawish, can you tell me? There's two types in sequential circuit. Do you know what are these?
D flip-flop.
No. In sequential circuits, there are two types. Rida?
Do you mean maybe registers and counter?
No. Can anyone tell me? Yes, ما شاء الله يديك مرفوعة. Abdulaziz Fahad, can you tell me?
Yes, doctor. Positive edge clock and negative edge clock, maybe.
No. No, Yusuf?
Synchronous and asynchronous.
Yes.
Reset.
Yes, synchronous and asynchronous. أكيد افتكرته الحين. So we have synchronous system and we have asynchronous system. These two types of the sequential, like your circuit is synchronized or not synchronized. So do you know what's the difference between them, synchronous and asynchronous? From the name, synchronous circuit mean each module, of course you have a system, the big system. So you have this module, this module, this module, this module, this module, and then there is some connection between them. If you say they are synchronous, all of them works at the positive edge of the clock only. So you know it's synchronized. At the positive edge, everything works and do some calculations, writing, whatever. That's it. Nothing, there is no positive edge, everything holds. So we call this synchronous. They are synchronized. بالعربي تزامن. Now, asynchronous means that, yes, we have a system. Some of the modules, they work at the positive edge, and some of the modules may work at something else. Like if there is a signal coming from the input, like a master signal or interrupt signal or whatever, it will work. It ignores the positive edge. Like you have a system and something there is working independent. So we call this asynchronous. So what does it mean in coding? It's extremely easy. So if you see always at positive edge of the clock, we know it's a synchronous because it only works at the positive edge of the clock. So I know this register module is synchronous. So if you add something here else, like if I say OR, you know what does it mean OR, and then check another signal, pose edge of, I've written wrong, so pose edge of clear, maybe. So I made it now asynchronous because now they always add works a different thing. Now it checked for the clock normally, but if there is a signal, a clear signal, it will run. So I made it asynchronous now. Okay, like a pseudo one, not exactly asynchronous. It works fine. But if there is a clear signal, it will just make it run. It will ignore the clock. So of course, you just say positive edge. Don't say clear alone. It will not accept it. You have to say, if you say positive edge, you have to say positive edge for all of the others. Okay, so remember that. So why? Why I made it like this? So as I said before, the clear signal is the most important. Sometimes it's more important that I have to include it here to make it run. Whenever there's signal, I have to run it instantly. I need to ignore the clock. Maybe I don't want to wait for the clock. I need to format it instantly. It's a very high important signal. So I made it here as an asynchronous. If there is a clear signal, it's immediately remove or like format the memory. Sometimes you don't need it. I have the time to wait for the other positive edge of the clock, and then it will remove. So do you understand the meaning of all of these, all of you? Any questions so far? Any question? Yes, Qusay? Yes, Qusay, معي?
Yeah, doctor.
Yes?
We have clear equals 1. What happens
If we have a clear is equal 1, what will happen?
if we have clear equals 0?
صوتك واطي ما اسمعك زي الناس.
No, doctor, is it clear?
Yes? Repeat again.
If clear equals 0,
Yes?
which if clear equals 0, we can't change the value of Q, but we didn't include it in this code.
It says if clear is equal 1, we format the memory. Yes?
Yes.
And then else. If I say else, that's if the clear is equal 0.
Not so else.
Yes, if I say else, like means if the clear is equal 0. You know the basic thing. That's a very basic information. Okay?
Okay, doctor, thank you.
Yes, no need. Like you say, don't say if clear is equal 1, do this, else if clear equals 0, don't do this. No, you just say else, it's enough. That's for the other situation. Like in default for the case, is the same thing. If you say else, the other one, خلاص. So the clear is equal 0. And load is equal 1. So I know we'll do this. Else means the clear is equal 0 and the load is equal 0, which means Q is equal Q, the refresh thing. And now I made the positive edge of the clear here, just for the sake, because in the same thing, in the manual, it's written there. All of us, we have to understand why. Normally, if I remove it, nothing will happen because the clock is very fast. I will make on the FPGA or like in the simulation, I will make it 50 megahertz, which is too fast. So of course, if the clear signal is on, it will format the memory instantaneously on our eye. But of course, there will be some delay. It has to wait for the next positive edge. But if I made it like this, it will make it instantaneous 0 for the clear signal. Any other question? Yes, Yusuf?
Doctor, why did you choose clear, not reset?
It's up to the system. It's up to the system. So some systems, they make the value of 0 as a clear. Like I want to use a clear and I want to format the memory to make it 0. Some other systems, they want to make it 1 as a format thing. I want to make everything as a value of 1 as a type of formatting. Okay, so you have to choose one of them. If you remember in the FPGA, all of you, if you remember when you turned on the Elvis board, you see the lit lights, all of them are ones. Do you see it?
I remember.
Yes, شفتوها كلكم. So you know that's the default of the Elvis system. It makes everything 1 as a default. So like it used whatever you call it, it used like the preset as a clear in its case. So some systems they use 1, some systems they use 0 as type of formatting. It's up to the system, okay? So here I am using clear. There is no need to use preset here. Any other question?
If I
Yes?
but if I remove clear now and put reset and go down and put if reset equals 0, Q will equal to 0 and continue like this. Will there be any difference?
You change the name only.
No, I put
فهمت علي? Okay, you're just changing the name. Reset and clear. It's the same thing. Okay, so it's the same thing. Any other question? خلاص. So let's do compile and let's see if there is anything wrong. You see nothing is wrong. So everything should work fine. I will not simulate. Okay, so that's it for the register. If you don't have any question, let's move on. I am seeing one attendant here. Abdulaziz Al-Hamidani.
Yes, doctor.
طيب ليش ما خبرتني لما دخلت؟ الله يصلحك.
I didn't want to interrupt you.
No,
while
no.
I was attempting to talk to you after the lab.
I will see you later, okay? I will see you later. طيب, now let's continue on. We finished with the register. So let's continue on. Let's go back to the manual. خلاص. You see in the manual, خلاص, we understand what's going on here. And now let's continue and see. I explained how the connection works. And now you have a module, because if you write the code, it's like this. Now you have a module that has an input of D and the output of Q, and we have a load signal as an input, clear and clock. Another information, sorry, I forgot to mention in the codes. So assuming someone says you write that code already as a 4-bit register. If someone says to you, no, I want 16-bit. So how to change it to make it 16-bit? Can anyone tell me? I want to change it to 16-bit.
You can use
Input.
N also.
0 to 15.
Yes, I will change both of them from 15 to 0. Don't say 0 to 15, 15 to 0, please. Okay, so 15 to 0, 15 to 0, I make it 16-bit. Very easy to change. Someone says 32, you just make 32 bits, 31, 31. So assuming you have a big code, like we have lots of stuff mentioning the same number of bits, like here and here and here and here. If someone says, I want to change it, you have to modify like all the other mentioning the sizes, like everything here, you have to modify it. It takes some long time. So there is a trick in the code. Maybe you learned it before, I don't know. In the Verilog, you can assign some variable encoding only, not like in the actual system or in the actual module, like some variable. I want to name some variable and then make that variable here as the sizes or maybe other things. So let's say here I will make a variable called n minus 1. So you know if n is 16-bit, n minus 1 will be 15, so it's the same thing. And then I will make this 15 instead of n minus 1. So I made it n minus 1 instead. فهمتوا علي ولا لا? And then I have to define, of course, if you say n, you have to define it. So now this n is not like a normal variable. It's like a variable for only writing the codes. Okay, you have to remember the difference. So this variable, I only use it for writing the code, just to help me only. So how to define it now? This special n, you define it here. After you say the name of the register, you say hash, and then you start defining. You open, I think you open a bracket, and then you say parameter. It helps me. And then you say n is equal to whatever value, let's say 4-bit. And then you close the bracket. So now you define something called n, which is 4. So you know it will be 4-bit. So 4 minus 1 is 3. 4 minus 1 is 3. So you know it's a 4-bit. And then you continue writing the code. It's the same thing. And then if someone says, I want to change it to 16-bit, very easy. I will change it to 16. If someone says 32, it's very easy. I only change it once. 32-bit or 64-bit or whatever, 90, whatever. يعني. So now you made it extremely easy to change whatever value you want. So that's an ability in programming. So if you want to use it later, whatever project you want. So now I make it 4-bit. So let's do the compile again. Does it accept that? Yes. Design, compile. Yes. Everything is fine. No error, no warning. Any question again regarding this? Okay. So hash, you open a bracket, you say parameter, n is equal whatever value, you close the bracket. Okay. So let's continue on. Let's see the manual. That's the register. And that's the code. Yeah, I have included the parameter. Okay, so but you have to understand what's going on. So everything is same as I have written in the code. And about the blocking and non-blocking assignment, it's mentioned in the manual. Don't say it's not mentioned if I ask you something in the final. So it says also the assignment to the output signal is performed using the non-blocking assignment. You have to be careful. They only use for the sequential and not the normal blocking assignment. We call this blocking assignment, which is used for the combinational circuit, like in the old times, always add star. You have to be careful because the non-blocking assignment uses the value of the variable right when you see it's like going to the details. But in general, to make it easy for all of us to understand, this one for the sequential, this one for the combination. Be careful. And now it's continue on. So we finish with the register. We understand everything with it. Now let's move on. That's it. Let's move on to the next one. Here we finish with the register. Now we have another application called counter. All of us, or all of you, do you understand what's a counter mean? Did you face it or study it or whatever?
Yes, in
Yes.
CI2.
Yes, a very basic thing, very basic application. Like I want to make a counter. So what a counter means, like it will count up every time. So I wanted to make it automatic counter, like when you run the program, it will automatically count up or down if you want. Or maybe I want to make some input. If there is an input signal, count up. If there is no input signal, don't count. Maybe if there is a count up button to make count up and then there is a count down. Maybe I want to make some reset signal, like if there is another input. If this input is 0, I will format the counter to make it 0. If you remember, I don't know in English, but المصباح الرقمية, do you know it?
Yes, yes.
Yes, المصباح الرقمية هذا, there is a very simple thing, subhanallah, subhanallah, okay, you press the button, it will count. That's a counter circuit, very basic counter circuit. You press a button, it count up. That's a normal count up circuit. We'll do something like that, but without a reset. You know, there is a reset. If you press it, it will format to make it 0. So we'll make a normal counter without a reset. There is no need because we'll make a simple one. So understanding what's going on, let's write a code for this one. So right click, new Verilog source, and let's call it counter. Finish. And now let's see how to write the code for it. So how many inputs we have and how many outputs we have. So for the counter, I will make it sequential counter, like there is a signal from the clock, it's running from the clock. Maybe I will not do it, okay? But here I will do it using a clock as a sequential element. And then we say there is an input. If there is an input, we count up. So of course it's an input. So maybe I will call it in P capital, whatever, just a name. So that's my input. If it's pressed, I know we'll count up. And of course I have an output. Maybe I will call it Y. So that's my output. That's the counter itself. And that's it. I think that's all of them. There is nothing else. Maybe reset, but I will not use it here as an example. So now let's define which one is input. Input. So we have an input clock, of course, and of the button itself, NP. And then we have an output. It's also a register, and it's a Y. So now, when you say counter, it count up to what? Like someone says, I want to make a counter from 0 to 10, or 0 to 15, or 0 to 20, whatever, 0 to 100. So here you have to define how many bits we need. So now, if I say from 0 to 7, how many bits I need? Can anyone tell me?
3.
8.
3 bits. Yes, 3 bits is enough to count from 0 to 7. So now if I want to count from 0 to 15, how many bits?
4.
4
bits. So I will make that from 0 to 15, 4 bits. So Y is a 4-bit. So that's the first thing, definition. So That's how you do it in writing whatever project you may face. Maybe in the final, I will ask you write something to do something. You just think how many inputs, how many outputs, how many bits you need, and these stuff. Okay, so that's it. Now let's writing always at, of course, I will make it sequential, so it's running only at the positive edge of the clock. Begin. Now, what should I say here? First, Shumari, Abdurrahman.
Yes.
What should I say here?
Statement.
If statement. Okay, أسهل جواب خلك السليم ها if statement يلا. So if statement, of course I need to check the button. I said the counter will only count up if you press the button. So if you say if the button is pressed, like if input is equal to 1, it's pressed. So we'll count up. So you know how to write count up? Abdulaziz and Ismail, what should I say for counting up?
Yes, we can just plus 1.
Which one? Plus 1?
You just add, it's just going to be INP equal INP plus 1.
But the IB is the input.
Sorry, 1.
1. Yes. So, you know, typically in C language, whatever you study, you know, to count up, you say Y is equal sequential Y plus 1. That's how you say for counting up. The new value is equal to the old value plus 1. That's how you write it. And there is something else, of course, you learn in the language, maybe C language, how to count up. You say plus plus. Anyone remember that?
Yes.
Y plus plus.
Y plus plus.
Yes, so I don't know if it's working here or not, but just to refresh your memory, yes, there is a plus plus you use for the C language. I don't know if it's working here or not, but we write like this: Y is equal to Y plus 1. We count up. That's it. Anything else? That's it.
I think that's
Else, okay.
Yes, that's it. So maybe if you want to do a refresh, yes, I'm hearing someone. If you want to do a refresh, yes, you can say else Y new value is equal to the old value, just as a refresh thing. But as we said before, it's not important. If you want to say it, if you don't want to say it, it's up to you. So I will remove it here. So I will not use refresh. So now, anything else?
End.
خلاص, that's it. Don't count until you have a signal input 1. So I will end it. خلاص, that's it for the always command. I will end it, and that's it. So let's do compile. Does it accept that? Yes. Nothing is wrong with it. So let's understand what's going on. We have it's running on the clock. So you see, it's checking the input, whatever there is a clock signal, like at the positive edge. So at the positive edge, it will see the input. Is it 1 or not? It will count. If it's 1, it will count. And then another positive edge, it will see the input. Is it 1 or 0? If it is 0, it doesn't count. It will stop. So understanding this, do you see any problem with this, with the code? Is there anything wrong with the code, or everything works fine? Yes, Abdulaziz?
How can we determine the start of the counter?
Yes.
I mean, if you want, for example.
I know what you mean. I know what you mean. فافهموا علي شباب. Please understand what's going on. خلينا نشوف. مطلق معي؟
Yes.
فضل الله معي؟
Yes.
عبد الله الوهيبي؟
Yes.
سعود الهاجري؟ سعود.
Yes, yes.
Yeah, please. Okay. Yeah.
So I was working on it.
نعم.
Well, I'm sorry for late. I was working on it and my laptop.
Okay. So the first issue, as mentioned, you see, it says if there is a signal, you count up. Now, the first thing you start the code. Now the code has been running at the first time. You see, now it's running. You run the program in the first time. Now there is an input signal, 1. And now it says y, the new value, is equal to the old value plus 1. Now the question is, what is the old value at that situation? It doesn't know. Do you see what's going on?
Yes, doctor.
It doesn't know. It says old value. Yes, we know what's going on, but the program, when you run it at the first time, it doesn't know. Okay, I don't know what's the old value to make it plus 1. You see, there is no instant value. There is no initializing value. So it doesn't know. It will give you an error. You go, I will add it 1, but to whatever. So to fix it, you have to initialize first. Okay, I will make it starting from 0. You have to say that in the code. So you cannot say it here, like after the begin, you say 1, make it 0 at the beginning. You cannot do it. If you do it like this, you see every time they always start, it will format your memory, and then it will do the plus 1 if there is a count. But you see, you're stuck 0, 1, 0, 1, 0, 1 all the time. You cannot do it like this. So how to initialize it and make it only once? And then it will start counting from that. So how to do initialize? You can do it here at the beginning. You see this line, output reg y as a 4-bit. You can make it equal 0 at the first thing. That's how you do it. So y is a 4-bit output register. Initially, it has a value of 0. So now it knows it has a value of 0. So when you start running the program at the first time, you give it an input 1, and now it says, yeah, the old value is 0. I will add it 1. Now it's 1, and then 2, and then 3, it will continue on. Do you understand this one, initializing? All of you?
Yes, doctor.
Okay, تمام. يعني ما حد انتبه إلا واحد. يعني please, when you design something, you have to think what's going on. Is it working or not? So let's do compile. Does it accept it? Yes. Now we fixed the first issue. Yes, Yusuf?
I think that I can initialize between the always and begin, right?
No, between the always and begin. No. You just say something here like something here equals 0, صح? Outside of the always.
No. I mean, can you please make a space between always and begin?
No. You cannot do it like this. Always begin, they are attached to each other. You cannot say like this.
Okay.
If you want something outside of the always loop, you can say something before it. But you cannot assign something. You have to say assign. You can do assign, of course, but it has to be outside of the always. But you cannot say assign y is equal 0. It will not accept it because y is a register. You see, if y is a register, you cannot say assign y.
Okay, got it.
Okay. So initialization, you can do it like this here. So let's do design compile. Any other questions? Yes, Rida?
When the y gets like to 15 and we add 1, is it going to be like an error or?
No, it will not be an error in this case. So y is a 4-bit, and then you start adding up. So of course you will reach 1, 1, 1, 1.
Yes.
15. So when you add another one, you see we have a 5th bit. We call it overflow. You study that.
Yes.
So
we'll start over.
Yes, it will overflow. The overflow, of course, there is nothing to be saved. It will removed, and then these will coming back to zeros. And then you'll start over. So when it reach 15, you add it 1, it go back to 0.
Okay. Okay, thank
so, yes, yeah, there is no error. Don't worry. Yes, Abdulaziz?
Yes, doctor. So this is only for counting up.
Yeah, which issue for counting up?
No, I mean this counter only counts up, not
Yes.
doesn't counts down.
Yes, now I design something counter for counting up only. If you want to do count down, of course, we'll modify the code to make it count down. Okay.
And the initialization will how it will be.
Yes, I can start from 0. I can start from 15. I can at least we have to start from somewhere. Okay. You have to start from somewhere, and then you say instead of y plus 1, you say y is equal y minus 1. Now it's a countdown if you want. Okay. Now we think that's everything, but there is also another issue with this one. We fixed the first one, but there is another major one. There is an issue here. Can anyone tell me what's going on? There is an issue with this code. No one. Okay, so all of you, reset. Yeah, if I want it. If I want to have a reset signal, you add another input, and then of course you make a condition. If that input is 1, y is equal 0. Yeah. Okay, but I don't want that. Yeah. Any other issue with this code? It will not.
Doctor,
Yes.
maybe we should write 0 in binary.
0 in binary? No. 0 in decimal, which means all the bits will be 0. We know that. No need to make it binary. If you want to make it binary, of course you will say 4 something bit, 4 zeros, but it's the same thing as 0 in decimal. Yes. Any other thing?
Maybe the no blocking.
No, non-blocking. We said we use it for the positive edge.
Maybe we need to make input equal to 0.
No, if input equal to 0, no need. Why we have to do something if the input is 0?
Maybe changing the NB.
Changing the
after
NB?
restart.
What?
After you start the code, how can
Yes.
you change the NB?
MB is coming from a button. It's coming outside. That's the outside signal. That's the input. You know what the input means. You connect it to a button.
Okay,
you connect the switch.
it.
Yes, if you press a button, I will connect to the button in the video. So if you press a button, it will count up. So yes. Yes. So Qusay, what do you have?
Should we put a limit for y?
A limit?
Because, yeah, what happens if we reach 15 and then we
I
put
answered
an
that
input?
question. Yes, if it reach 15 and you put another input, it will be overflow and it will go back to the 0.
Okay.
Yes, so you want a limit if there is a limit that's asked to you. Like I want to count from 0 to 10, maybe. So there's a limit. Yes, I don't want to exceed that limit. Of course, you'll modify the code. If it reach that limit, it go back to 0. But here, like I have a natural one. So it's naturally, after it reach 4 once, naturally it's going back to the 0. If you add 1 because of the overflow. So nothing like this here. So Abdulaziz, Fahad?
Yes, doctor. Maybe there's synchronous and asynchronous.
No, nothing like that. Abdulaziz Said?
Doctor, when the we add +1 y equal y +1, we should add a 1 bit only, not 1 in decimal.
It's the same thing. 1 in decimal is the same as 1 bit. Same thing. Do you understand? Same thing. If I say 4 bit 0001, it's the same thing as decimal 1. So yes, تفكير سليم, but yeah, it's not here. So the hint is, the clock, I will connect it to 50 megahertz. What will happen? I will do that. I will connect the clock to that 50 megahertz. Can you tell me what will happen to the circuit?
Doctor, maybe the propagation delay?
No, not propagation delay. Abdulaziz?
Count very fast.
It will count very fast. افهموا علي شوي. Please understand. Hamza, with me?
Yes.
Yeah. Not calculator. I don't want calculator. Why? Sorry, I want to run a paint program just to make something fast. So please understand. So now you have a 50 megahertz clock. So it's a fast one. I'm just drawing. It's a very fast one. Yeah, just very Fast one. So now that's a clock signal. And now you pressed a button to want to count up once. So when you press a button, you are very experienced button pressing, and it's like this. That's only one press. You see, 50 megahertz. You know the period is very small here. The time period is very small. So when you press the button, what does the system see? That you have a long press. You understand what's going on? So now, how many positive edge? Now it follow 1, 2, 3, 4, 5, 6, and so on. 7, 8, and also including here 9. So what will happen? Only one press. It counts how many times? 9. You see, many times. In general, many times. You understand what's going on?
Yes, doctor.
في حد مش فاهم؟ Assume everyone understand. Okay. So you see, when you press a button, you know the system is running at 50 megahertz. So like less than a microsecond. Like, so when you press a button and you are very fast, like press only one press and then remove it. So it seems like you have pressed for a very, very long time. So if you want to count up, it counts like 500 times or 1000 times or like 20 times or whatever. Everything is a random number. So that's an issue here. You see what's going on? So that's an issue here. It's not counting up once. So you see in the code, always at the positive edge of the clock. So you see, oh, you press a button, it will count up. And then going to the next positive edge, it will check. Oh, you're still pressing the button, I will count up. And you're still pressing the button, I'm counting. We see the system, what's going on? Pressing the button, it counts many times. So how to fix it? That's the major issue. How to fix it? I want, if I press the button, whatever the type of pressing, if I press the button, I want to count only once, not many times. And I don't want to miss it. Like there's a case that you press a button, nothing happens. If in some Chinese equipment, whatever, if you press a button, nothing happens. So no, if I press the button, it's guaranteed that it will count only one. So I have to fix it. I cannot fix it in this module. In this module, I cannot fix it. I have to fix it in some other modules. So which means that your button is here. You have to have some module to fix the long pressing, and then it gives only a special type of pressing that's going to your counter. Okay. Okay, so I have to create another module, take that input, fix it, and then going to the counter itself. So I will create that module. So it's already compiled. Now let's create another module to fix the button pressing. So let's call it pulsar.
Doctor,
Yes.
can we just put or a positive edge for the press?
That's a valid solution. So you say, okay, I can fix it to make it only work at the positive edge of the input. So you say or input, positive edge, sorry, positive edge. هذا الحل الثاني ما أدري غريب بس واحد انتبه. That's another solution. So you can say the positive edge of the clock and also or the positive edge of the input. So you know when you press it, there is only one positive edge, because you see if you keep pressing it, it's still one positive edge. If you remove it, the positive edge is gone, and you press again, there is only one positive edge. So you guarantee that it will count up. Any do you agree with that? في حد معارض هنا؟ It's supposed to work like this. Anyone disagree? So all of us, we see, yes, it's supposed to work, but it's not going to work. If you implement that on the FPGA, it will give you lots of warnings, lots of errors. Okay, because of this one. It doesn't accept that, because you want to make a positive edge of a button. Of a clock, yes, because the clock is a very pure signal. Okay, so we know it's a very pure one. Yes, I can say the positive edge of the clock. But for the input, which is mean the switch or whatever, the button itself, you cannot do the positive edge of it. Why it cannot accept? We know it's supposed to work, but it cannot accept it. So why? So that's a button, like you pressing a button. So that's a button and you pressed it. So we assume that if you press it, it's only giving one positive edge. And then when you release the button, it should going to the 0. That's the ideal case. But in real life, if you press the button, it will be like there is something called bouncing. You know, with the two metal contact, when you press the button, there is a chance, like in physical terms, there is a chance that it will bounce. Like it hit each other and then bouncing and then it's bouncing and then it's going to the complete conduction. So there is a bouncing issue. They call it advanced. هذا معلومة لكم. شوف advanced. They call it bouncing issues if you press a button. So that's why the Xilinx program, the IC, it cannot accept, because there is a chance that a bouncing can happen, and I don't accept that as like a syntax, as a rule. Do you agree with? Do you understand what's going on?
Yes.
Yes.
Yes, you hope so. So this bouncing can be fixed physically. It's not like you're doing a program or whatever. You can fix the bouncing issue. So if we attach a capacitor in parallel with it, with a button, so if you press it, the button, it will remove the bouncing. That's a physical advanced. If you want to do whatever project in the future, if you have a button, you add a capacitor in parallel to it. So what's the capacitor doing? You know, the capacitor by nature, it refuses the sudden change in voltage. So all the sudden change in voltage, it will be removed. So that's the bouncing, and then it's going completely on. So there is only one positive edge. Yes, it's a rigged one, but still it's count as one positive edge. So like if you have some system that has some buttons, if you see the PCB itself, like controller for the PlayStation, whatever, you see there is a capacitor. For each button, there's a small capacitor in parallel with it. That's to fix the bouncing. They call it debounce capacitor. But still, the Xilinx or the ISE program still refused, because there is maybe a chance, and I don't want that. Okay, so yes, it's supposed to work. Yes, but because of some rules, we cannot do it. So قصة مطولة, long story, but it cannot be accepted. Now, any other questions? موضوع طويل جدا. Any other question? Yes. So we say we fix it, the button and these stuffs, I want to fix it. So I create another module to filter that pressing. I want to filter it. So I will call the circuit is a pulsar circuit, or like clock pulse or whatever. So that's the name, general name. So that's the module. It's responsible to give me only one pulse if I press the button only once. So which means that if you press the button, so let's go back. Oh, so if you press the button, it will be a long press, whatever. So I want to give only one pulse. So this module will give only one pulse. So this one pulse, it's going to the counter, and it's supposed to count only once. Because if you press this to the counter directly, you count many times. So that's the target here. So now how to do it? In the coding, how to do it, we go back to the manual because it's already explained. So let's see the manual itself. So it says I want to use, if you want to filter the button or only give one pulse, that's how you do it. Please focus with me. So that's the circuit. So the first thing, that's the button here, and that's the output of it. It should be one pulse. And then it works at the clock signal. So of course it's a sequential thing. It works from the clock. And now the first thing you do, you make a delay. You see, that's the push button. So we have the first delay. You take the whole button thing, you make a delay of it. And then there is a delay too. So which means that you take the delay one and make another delay. You copy it and make another delay. And then there is another delay, the last one, delay 3 we call it. You take it and then you delay it again. طيب, what's the point? And then there's an AND gate here. So the AND gate will take the delay 1, delay 2, and then not delay 3. So there's an inverter gate here. So not delay 3. So they say the output will be only 1 pulse. So let's understand what's going on. Going back, delay, what is it يعني? So let's going delay, I think. No, not delay, pulse for the pulsar. So please understand. So that's the clock, assuming that's the clock, 50 megahertz, way fast. And now you press the button. So when you press the button, it's like this. You press it twice. So now it's like this. That's the first pressing, and now that's the other one. Of course, it's not accepted to the counter because it will count up 1, 2, 3, 4, 4 times. We cannot do it. So the first step, رضا معي؟
which doctor?
Yes, الوليد.
Yes, doctor.
Yes, علي حماد.
Yes, here.
Yes, انتبهوا معي بالله عليكم. لو سألت في الفاينل مو شغلي بشرح لكم. So that's the input. The first step, it says make it a delay for that input. So you see the full input, I will take it and make a delay. So it will be like this. That's the delay one. So you see the same input with some delay. So the amount of the delay, it's between this and this. So you see that's the amount of delay. One cycle of the clock. You see, one period. So it will delay it 1 period. تمام. We finish with that. And then it says we have a delay 2 that delayed from delay 1. Lots of delay. So let's see. That's delay 2. Same thing as delay 1 with a bit of delay. So you see another period. Now, let's make a third one. That's the third delay. Is from the delay 2 with 1 cycle. And now it says I need to do the AND between delay 1, delay 2, and not delay 3. So which means that they have to be 1, 1, 0. صح ولا لا يا شباب؟ 1, 1, 0.
Yes.
صح؟ طيب متى بتحصل؟ Where is it? So I see that this is 0, 0, 0. This is 1, 0, 0, not. And then we have 1, 1, 0. So this period, the AND will give 1. Let's see the other cases. No, this one is 1, 1, 1. This one 1, 1, 1. Still not going to trigger the AND gate. And this one 0, 1, 1. You see, nothing there. And then let's go continue on. For the second press, we have still 1, 1, 0. هتعطيني pulse. Now we have a pulse here. And now it's going back to the 0. So the output of the AND will be like this. So we have a pulse here. 1, 1, 0. We have a pulse. And then for the other press, we have another pulse. شفت المشوار هذه كله? That's a long story just to give one pulse. So let's see, or 2 pulses. If we press 2, we have 2 pulses. So now let's see the pulse itself. What's the length of the pulse? 1 cycle, صح ولا لا?
Yes.
Yeah, 1 cycle, 1 cycle exactly. So now, if you put that to the counter with the same clock, because the counter clock is the same as the clock for the pulsar circuit. So if you put that to the counter, you know, it's impossible to count twice. صح ولا لا?
Yes, it's impossible.
Yes, it's impossible because only the length only cover one positive edge, because this one is already going back to the 0. So it doesn't count this one. So I know it will only count 1 because the length of the pulse cannot cover 2 positive edges. So I know it will count once, and you cannot miss it, because this one, if it enters whatever location, you cannot miss it because it will cover, guaranteed 100%, it will cover 1 and only 1 positive edge using that pulse. So now you take the output of that module and feed it to the counter, and you know you will count only 1 time if you press it 1 time. So you have to release the button, press again, another pulse. Now, do you understand what's going on here? Any question? Nothing? MashaAllah, tabarakallah, nothing. Okay, so I assume all of you understand what's going on. So now let's write a code explaining these stuff. So, yalla, bismillah. Yeah, Abdulaziz?
Doctor, did we fix the issue of by using this method?
Yes,
Like
if I
adding
use
delay.
this method, yes, adding the delays and these stuffs, I can fix the button. You say the problem, if I press the button, it will count many times. So if I fix it like this, I guarantee that if you press the button, it will get only one pulse. And that pulse,
So
you feed it to the counter, it will count only one time.
in this example, we consider a one pulse.
Yes, one pulse, yeah.
I mean one press.
Yes, one press.
Okay.
Yeah, if you press it once, it will give one pulse. If you press it another, it will give another pulse. Even in the future, whatever you press, it will give only one pulse. خلاص؟ بعد تقول طيب في بعض الأجهزة إذا ضغط حيبدأ يتم ضغط. That's another system. You can add another thing, like if you monitor the input, if it's pressed for a certain period of time, you do some other stuff like repeat or whatever. Yeah, that's advanced system. But here, I'm talking about here, it will get only one pulse. Yes, Rida?
How can we decide how many delays we need?
Yes, how many delays you need? If you increase the number of delays, you get a very pure signal because you know the button, they may have some noises like bouncing and some other noise, physical, mechanical, whatever, there are some noises. So if you increase the number of delays, you fix that noise. So you guarantee that it will be one pure pulse, like maybe 4 delays, 5 delays. But the disadvantage, it will introduce a delay. When you press a button, there will be some delay until you get something in some action. واللي يلعبون البلاي ستيشن والاجهزه هذه يعرفون المشكله هذه. There is a delay. You cannot press something and then there is a delay like a millisecond or whatever until it appears in some action. You don't want that. So the minimum number of delays, 2. Delay 1 and delay 2. You can do it using only 2, like maybe 1 0 is enough. So in this example, we used 3 delays. Just whatever يعني. We just used 3 delays. And you know, نعم.
Does it like depends on the clock or like?
Yes, it depends on the clock, of course. And if the clock is very fast, yeah, you may introduce like more delays, 1 or 2 or 3 or 4, because one cycle, yeah, you can ignore. You see, that's the pressing, and there's a delay up to here. That's the pulse. You see the amount of delay. These are like a microseconds, or maybe a part of microsecond. Yeah, I can ignore it. But if you increase the number of delays, like lots of delays, yes, that's a problem. You have to. Okay, Sammy.
Doctor, how do you know the amount of the delay?
How to know? It's up to the system itself. What's the clock? What's the button? The behavior of all of these. You have to like study them, and then you decide how many delays you want. As I said, minimum is 2. 2 is enough.
No, I mean period, because there is like one
I don't know what you mean.
Delayed the input by
yes.
It's a 1 period.
It's supposed to be 1 period. Yes.
Okay.
1 period. The delay 1 is supposed to be 1 period from the input. Delay 2 is supposed to be 1 period from the delay 1, and so on. You see?
Okay.
Yes, another question?
Yes, doctor. Can we decrease the delay of the output if we add the first delay and the inverted of delay 2 and delay 3?
If you do that, yes, you can do that. Yes, to make it 1 0 0. Yeah, mashallah, عبقري. Okay, so you can make it 1 0 0. That's a pulse here, and I saved 1 period. You can do that, of course, but in our example, we say 1 1 0. You just pick a special occurrence that only happens once. Yeah, you're right. I can make it 1 0 0. تمام. Any other question? خلاص. So let's write a code explaining all these stuff. So يلا بسم الله. So how many inputs we have? We have a clock, of course, and We have the button itself because I am pressing the button. So maybe I will call it button or whatever. Yes, I will call it button, all capital. That's a button. And then we have an output. So that's the pulse. So maybe I will call it out P, whatever, just the name. So that's the output, the pulse that's going to the counter later. I think that's it. That's all I need. And then we have an input. Of course, the clock is an input, and the button itself is the input. And then we have an output called out P. Maybe I will make it register. Let's see later what's going on. That's it. So now let's try it using always command. MashaAllah, مكتوبة زي الناس. So always at positive edge of the clock, because that's a sequential element, positive edge of the clock. And then we say begin, and let's see. So the first step, let's go back. Let's close this. We don't need it. So the first step, it says delay 1 is equal to the input with this amount of delay. So we have a variable here called delay 1, delay 2, delay 3. صح ولا لا يا شباب? Variable. Well, you have to define something called delay 1, delay 2, delay 3. معي?
Yes.
Yes, so they are not outputs and they are not inputs. So how to define them? We have to define it at the beginning. Yeah, wire only used for gate level. زي ما قلنا. Always والwire مش زي بعض أبدا. You cannot say always and then you say wire before it. You cannot say it. They are not together in one code.
So can we start?
Rig?
Yes, rig, if you see the manual itself. So the command rig, we used also for the output rig, because the always thing, I explained it, the experiment 2, I explained that. But also the command rig, I can use it to define variables. They are not inputs, they are not outputs, like wires, but for these type of codes. So you say rig. So let's define delay 1, delay 2, and delay 3. So I can use rig command to define some variables. They are not input, they are not output. Okay, so begin. So the first thing, delay 1 is equal to the input with a delay. So how to say it? Extremely easy. You just say delay 1 is equal to the input. That's it. Or the button itself. That's it. This line serves the purpose. Okay, that's it. The non-blocking assignment, this one, it has a feature. If you say equal like this, it will give a delay. It's a feature for the non-blocking assignment. So that line will be like this. The delay 1 will be equal to the input with a bit of the delay, the button itself. So that's it. We serve the purpose. Yes?
What did you say about the non-blocking assignment?
Yeah, the non-blocking assignment.
Yes. What about it?
Yes, the non-blocking assignment, it will give the delay. I said delay 1 is equal to the button. صح ولا لا?
Yes.
Yes, so delay 1 is equal to the button. It will be like this. It will give a delay by itself.
Okay.
It will be like this. If you say equal, and you can do that, يعني أنا قلت لكم قبل شوي you cannot, but you can do that if you want. If you say equal, it will be exactly equal. There is no delay. So of course, if it will be exactly equal, this concept will not work. If you make it exactly equal, like delay 1 is exactly equal to the input, it shouldn't work. We cannot do this type of method. So we have to make it non-blocking, which has a feature that it will make a delay to it. So that's it. And then let's go back. We have a delay 2 is equal to delay 1 with a delay. It's a very simple thing. You say delay 2 is equal to delay 1, and from the nature of the code, it will give a delay. And then you say delay 3 is equal to delay 2. Yes, lots of discussing, and we see it's a very simple to execute, just one line. Yes, Al-Walid?
It will delay by 1 cycle.
Yes, it will delay by exactly 1 cycle of the clock. that line only, it will give a delay exactly 1 cycle of the clock. خلاص؟ تمام. So that's it. And then we have that we did all of these. We did all of these. Now the output is equal the delay 1 ended with the delay 2 ended with not delay 3. So we have some Boolean expression here. So Boolean expression, you cannot like do it here. You cannot say like output 1 with and. Maybe it will take some time. Maybe it will introduce some warnings or error. So you can exit from the always. Now I am exiting the always. And then you can say assign. The normal assign, the Boolean expression. So assign the output P is equal delay 1 ended with delay 2 ended with not delay 3. So when I say assign, the command assign output, the output cannot be registered. You remove it. If it's the output inside the always, you have to say register. But here, in this case, is not. So now I fix the code. That's everything. Any questions so far? Any questions so far? You see, التطبيق سهل جدا. حسن المسلم معي؟
Yes.
عبد الصبور؟
Yes, doctor.
Yes. حاتم؟
Yes.
Yes. يلا. حاتم معي؟
Yes, yes, with you.
Yes. شكلك نعسان. باقي مشوار هذا معلش. Okay, so we say design, compile. Yes, رضا?
Why is there not before delay 3?
Because it says like this in the design, not delay 3, 110. It has to give an output of 1.
Oh, okay.
That's the design thing. أو زي ما قال الرجال 100 is still will solve the problem. Okay. There is no question. Let's compile. I think I did it before, so let's do compile. There is nothing wrong. خلاص, that's it. That's how you solve it. And any other question? No. So let's see the counter. Did I compile it? Yes. So that's it. Let's go to the next thing. So we fixed the problem of the delay. So now let's see the manual. That's it. Yeah. So now what's the project itself? So what should we do in the project? So the lab work. So assuming that all of you in the lab, if you're coming to the lab, we're supposed to be coming today in the lab. The first thing I will do, I will say to you, implement that code to the FPGA. هذا المشوار كله. We just implement that whole system to the FPGA. So we have here in the below, you see there is a clock, there is a pulse, there is a clear, there is a load. That's the inputs, and also there's a switches coming to the register. That's all inputs. And now let's see the counter part. هذا الcounter. You see the counter, the clock is coming from the master clock, and the input, you see the up count, the count up is coming from the pulsar. That's the pulsar. So that's the input. So you press a button, it's going there, and then it will give one pulse, is going to the count, and it will count up. So we know that. And then the output is coming to this weird thing. We'll explain it later. And now for the register, we know the register, it has a clock, master clock, and then it has a clear signal. Of course, that's a button. And there is a load signal, we'll make it a button. And then we have a switches. You know, we have to arrange some inputs to test it. So we have these inputs. And then if you press the load, of course, the inputs D will go to the queue. So now it's saved. And now the output of the register, it reads by the same thing, this one. So we're supposed to make this system working instead of LED lights. You know, all the past experiments we did LED lights. صح شباب ولا لا? The outputs.
Yes,
yes. Yeah, so LED light for normally في الcounter, a LED light is supposed to be 4. Like 0, 0, 0, we know it's a 0, and 0, 0, 1. And then when you count up, it's going by binary up to 1, 1, 1. And the same thing with the register. Like if we saved this type of memory, like if I make the switches 1, 1, 1, 1, you press the load, you say your 1, 1, 1 is to the register. So that's one way. Like in binary way. In general, it's a binary thing. So I don't want that. I want to see the number itself. I want to convert this binary number to a number. I can see it. So if you remember in the Elvis board, did you see like a digit display?
Yes.
ما
Yes,
انتبهت.
yes.
Yes, ما
Square
انتبهت.
one.
Yes, there's a digital display or like digits. Let's see if where is it? Yeah, that's the FPGA. So that's the diagram of the FPGA. If you remember, that's the Elvis board itself, the whole board. That's the FPGA. If you remember, these are the buttons and these are the switches, if you remember. And then these are the LEDs, and that's the 7-segment, we call it 7-segment display. All of you see it? If you remember seeing this? ما حد يرد؟
Yes.
Yes, والصورة ملونة يعني you see that's the 7-segment display. Will you use that? So now how to use it? We have to understand what is the 7-segment display. Okay, so we have to understand the construction of it. So I think some of you know how to use it. Anyone can explain to me, or like just say to me if you experienced with it before or not? Anyone? ما حد بيعترف. ما بوري نفسي. You already took it. Okay, so you know it. So let me explain, like if you maybe you didn't remember, or maybe whatever you call it, the construction of the 7-segment display. We need to understand the construction of it itself, and then we can send the signal to it and then display the number. So explaining the construction of the 7-segment display. So now let's see the delay. Yes, that's the module. After you do everything, that's the module, the push button, the clock, and then the output. And that's the internal thing we already did. Delay 1, delay 2, delay 3, and then the AND gate. We already did that. خلاص. Now let's see the last bit, the 7-segment display. So the 7-segment, we know why they call it 7, because it contains of 7 of these segments. So we have this segment 1, 2, 3, 4, 5, 6, 7. And they call them some names. So when you say segment A, you know the A will be the top. So now A, and then B, you go to the right side. So A, B, and then you go down C, D, E, F, وفي النص G. So A, B, C, D, E, F, G. So you have to understand the name and memorize it if you can. And it's very easy. You start from the top. And these segments, they are LEDs. Typically, they are just LED light, but they arrange like these. So we have 7 LED lights, and they arrange like this. So if you turn on this and turn off this and turn on this, turn on this, you can display some number. فهمت علي شباب ولا لا؟
Yes.
Yes, so I need to control it. So I have like 1, 2, 3, 4, 5, 6, 7. So I need 7 control signals to send to the 7-segment display to tell which one is on, which one is off. So now let's explain the connection between all the segments. We say they are all LED lights. So now let's go in here. So did you study the diode itself? I think all of you just study it, صح? The diodes.
Yes.
Yes, درست الدايدز المفروض قفلتوا عليه او يمكن دخلتوا فيه خلاص. So the diode, the LED light is a diode, same thing, but they call it الاختصار حقه they call it light emitting diode. So it's just a diode but has the ability to emit some light. So you know the diode, when does it pass the current? If the anode is higher than the cathode, you already know that. And the difference in voltage, anyone can remember? They told you in the lecture, what's the difference in voltage? The anode should be higher than the cathode. The voltage difference.
0.7.
Yes, typically 0.7. صح ولا لا؟ كان آخر واحد يتكلم. Yes. Okay. So see, 0.7, it's coming from what? From the silicon itself. So a pure silicon, if you make a diode from or LED from a pure silicon, the voltage difference has to be 0.7. That's the number. They told لازم تعرف فين جات الرقم هذه. So you know 0.7 from the silicon, and the normal silicon should give you a red light. So if you see a red light, you know it's constructed from a normal silicon, a pure one. If it has some doping like other elements going inside, there will be other colors like green or blue or white or whatever other colors. So when you buy a LED light in bulk, you know the cheapest one will be the red light, the cheapest one, because it's just a silicon. So when you see like any equipment and you see only red lights, they save some money. Just like an information for you. So the anode should be higher than the cathode. So now we work in digital. So 0.7 is meaningless to us. So we say if anode is higher than the cathode, or in terms of digital, we say anode is 1 and the cathode is 0, we'll make the diode on. So the diode will be turned on. Otherwise, you see there is no current. If both are 1, there is no current. If both are 0, there is no current. And the anode is 0 and the cathode is 1, of course there is a reverse bias, nothing. So it will be off. فهمنا كل هذه. فهمتوا يا شباب؟ تمام.
Yes.
Yes. So, and also, by experience, maybe some of you experience with the LED light, if you want to use it in whatever project, you have to add some resistor to it. انتوا درستوا انه في internal resistor for the diode. I think all of you, when you study the diode, there is an internal resistance and then you do some calculation, whatever. But if you do in projects, you put a LED, you have to put some resistor. Anyone with experience can tell me what's the value of the resistor typically? ما حتشتغل أبدا. Okay, it's supposed to be, anyone? It's supposed to be 220 ohms. Normally, typically, they purchase a LED light and then they put a resistor 220 ohms in series with it. Why? Because it needs to protect the LED itself. Because if you do it directly, حطيت الفولت على الدايود نفسها, what will happen? The internal resistance of the diode is very, very, very small. So which means that the current will be extremely high and it will burn out. Instantaneous, it will burn out if you put directly to the voltage source. So you have to have some resistor to it to limit the current, to protect the diode. Okay, please understand that. So don't burn the LEDs in the future. Put a resistor to it. So معلومات خارجية كلها, extra information. Now let's go back. The arrangement of the segments. We say they are LED lights. So now, the first segment is like this. That's the diode or the LED, and then we have a resistor in series with it. We don't care, of course, but we have to have some resistor to it. What we don't care. So now we assume this one is the cathode, and this one is the anode, okay? Now, we say we have 7 of them. So, which means we have 7 of these arrangements. So now, let's count up 1, 2, 3, 4, 5, 6, 7. That's the 7 LEDs, or the 7 segment. And now we assign each one for the segment. So now, the top one will be the segment A, LA. And this one, B, C, D. So A, B, C, D, E, F, G في النص. تمام. And then we have the cathode signals here. So now, how many signals I need to send to the whole system? I need to send the A, B, C, D, E, F, G, like ones or zeros. And also I have to send the cathode. صح ولا لا يا شباب?
Yes.
I have to send the cathodes. So now how many signals I need to send in total? 14. 7 here, 7 there. So 14 signals, which is too much. Okay, it's not practical. 14 signals to control only one digit. That's too much. So one measure to save the number of signals you need to send by making all of these, we call it common. So we make all the cathodes common. So you see, they are all connected together, and then only one signal awaits from you. So now, how many signals we need to send? A, B, C, D, E, F, G, 7, including the enable, 8. 8. So what is this enable? If I make the enable 1, the signal, this one, if I make it 1, what will happen?
Off.
All the diode will be off.
All the diode will be off. مستحيل, impossible to be on. So now you have the ability to control the digit. I can make it completely off. So enable, if I make it 1, it will be off completely. Reverse signal, انتبه. And now if I make the enable 0, what will happen?
It depends on
A,
the
B, C, D.
It depends on the segment itself. Now it depends on the signal. If the cannot A1, it will turn on. If the cannot AB0, it will turn off. So normally we have to make the enable signal all the time 0. Okay, so be careful of that all the time. Or maybe if you want to disable it, make it 1 if you want it. So all the time 0. Now, if I want to display number 8, how should be the arrangement for all the segments?
All of them.
A, B, C, D, E, F.
All of them on.
all of them ones.
All of them صح 8 1 2 all of them will be on, which be the 8 صح ولا لا? And now I have to make all of them ones. So if I want to display number 0
without the G.
without the G, so the last one has to be off. So now you understand the arrangement for all the numbers. So تمام. Now let's go to the examples. Let's see. That's the number 8. So 8, we have to make everything on. Now let's see the number 1, or like maybe this one. If you want to display a dash, like a minus sign in calculators. So how to make it just only the G, صح ولا لا? Make it
G,
enable.
yes.
Yes, only G, and all the other segments should be 0. تمام. Number 0, as I said before, is the reverse. Make all the segments on except for the G, make it off. And number 1, خلاص, we know. Off, on, off, off. That's the code. So now we have some coding here. And then for the number 2, so it'll be 1, 1, 0, 1, 1, 0, 1. 3, 4, 5, 6, 7, 8. So now you have some coding. For each number, you have the codes for the A, B, C, D, E, F, G. Of course, you need some table. Now let's see the possibilities we have. So we have 7, 8, 9. Don't forget 9. You have to include this one. لا تحط لي 9 العادية. That's the 9. And also number 6. It has to be. What's going on? غريبة شوي. Let's open it again. Yes, I don't know what's going on. So number 9 and number 6. Include the top one, please. Don't forget. And then for the number 10, of course, I cannot say number 10, but in hexadecimal, I can say 10. صح ولا لا يا شباب? A.
Yes, A.
A.
Yes.
So A, that's the 10. Of course, A, you can display it. Very easy. You just remove the last one. That's A. B, I can say it 11. B, you can make it small, capital out of the options. So you can say small. Small B, that's 11. C, capital C, I can do it. D, small one, I can do it. That's D. And then E, tamam, F. So now I have the ability to display all the hexadecimals from 0 to 15. Here from 0 to F. Now let's continue on. Maybe we can display special characters like G, for example. I can display G if I want. I can display H if I want. I can display L. I can display N. This one represent N if you want. And whatever this character, you can display it. And then we have O. You can display that. And P as a capital P. And R, small r. You can do that if you want. And then S, you know, 5 and S, they are the same thing. You can display that, of course. U as a capital. And then we return back to the 8. So we have some possibilities here I can display. So of course you need to have some table to decode all the numbers. Like assuming I want to display from 0 to 15, like 0 to F in hexadecimal. So these are the codes given to all of these. So now it says here, if I want to display number 0, you have to make it on, which means 1, 1, 1, 1 until the last one will be 0. So now you have some coding for each one. You see the number 8, all of them are 1s. And see the A, only the bottom one. So A, B, C, D, the bottom one will be 0. And so on. So these are the codes for each number in hexadecimal. So now I need to create a module to do this. Like if the input is 0, make the output these type of segments, and then we send that to the 7-segment display. Okay, you see that the 7-segment display needs from your side these information. You have to send it. So I have to create a module that is responsible to convert my number to the hexadecimal form, or like to the segments form, and then send it to the 7 segment display. Now let's write a code for this one, the last one. خلاص. So let's go back and let's write a code for this one. So it's a long job. I have already written the code in somewhere else. So I will tell you how to add. You can add from whatever workspaces or whatever other programs you've written a code there. You can import it here. So how to do it? You just right click. Instead of saying new, you say add files to the design. And then it will ask you which one you want. So I think it's in this desktop, and then what, I forgot what does it say. It's something starts with the codes, yes, codes, and then hex76, this one. So let's see, it's already there, hex76. Let's open it. I have imported the code. You can write it, of course. We understand what's going on. We can write it from the beginning, but you don't have time. So let's see. That's the module. We call it hex76, converting from hex to it's supposed to be hexadecimal, but whatever, yani just a name, hex76. And then the input. So I have an input. That's the 4-bit input, because hexadecimal can be represented in 4 bits. So like I take from the counter in general, like I'm taking from the counter, and then I convert it to A to G form, like the segments from A to G. And of course I have to send the enable signal because it awaits from me the enable 0 or 1. I have to send it. So 1 input, 2 output. We have an input X because it's a 4-bit, of course. And then we have an output enable, it's a single bit, either 0 or 1. And then we have an output reg A to G. That's the segments, the arrangement of the segments. And then I say always add. This, I cannot make it always add positive edge of the clock. There is no need. It just like for the 7 segments display itself. So like that's a combinational part for the 7 segment display. So there is no need. Always add star. Now, case X, because now I see the input X. So I make a case statement. Now I say if the X is 0, like 4 binary zeros, maybe, and then the A to G, you have to write the segments. So, okay, the segment A, you see the first one is segment A, 1, 1, 1, 1, you see, until the last segment is off, the G is off. So now you write the segments arrangement for every number. So that's the number 1. You write the segment arrangement, and then up to the 10. So 10, assuming the input is 10. So I wrote it in hexadecimal, whatever, you see, I can do that. So it's single quotation H when means hexadecimal, and then A. So if you received the input A, what will happen to the A to G? You just display the arrangement of the segments for the letter A. So we have 1, 1, 1, and the bottom one will be 0, and then other segments will be 1. That's the display. And then for the B, C, E, D, E, F, G. Okay, any question regarding this code? Nothing. Yes, Abdulaziz?
Doctor, down we use enable as 0 and assign. Why did we use this?
Yes, so now after you finish all of the cases and then you close the case, so what will happen? I said assign. Of course, I forgot to say begin. زي ما قلنا لكم begin و end. And then after the end case, there will be an end. Now I am outside of the always command. Now I said assign enable equals 0. You know, you have to send the enable either it's 0 or 1. ما قلنا الكلام ده صح ولا لا؟
Yes, we say that, but we say we have 2 conditions. It depends on the anode.
It depends on what?
In the anode.
On the anode, yes. If it says 0, it depends on the anode, which is this code. خلاص. You see? That's the anodes. And this is the common cathode.
Okay.
I have to say, if I say enable 1, it will be off all the times. It will ignore all of these because it will be off all the time. So I have to say 0. I have to send it as a 0 all the time. Any other questions?
Yes, doctor. Can you put instead of hexadecimal put just decimal like 10, 11. Do the same.
I can say yes, 10, 11 instead of this one. I can do that. Like I will remove this and I will say 10. I can do that, of course. But I just do it. Why I did it? Like the reason, because I want to see the letter A, how the arrangement is, because I want to say the segments. Okay, just for my side, yani. You can say 10, 11, 12, 13, 14, 15 if you want. Any other question? Tamam.
Doctor?
Yes.
So here, like when you put the hexadecimal A, B, it doesn't matter if it's capital or small.
Yes, yes, it doesn't matter if it's capital or small. Okay. Now I think that's all of it. Any other question? Hatem? Hatem? Hatem معي.
Yes, yes.
Yes. تمام. Okay, so that's it. Now let's do the compile. Where's the design? Compile. خلاص. So now everything has been set. We understand all of it. So let's go back to the manual and let's go back to the last circuit we need to do. That's big circuit. So now I am ready. I have defined all the modules. You see, I have defined all of them in the code. All of them are here. I have defined them all. So now I will create the main circuit and then I will call all of them and then I will do the connections as a gate level. طيب. So now we have 2 digits. We say we have 2 digits, one on the left, one on the right. Okay, so each one of them is independent of the other. So which means that I can make the counter connected to the مثلا the left one, the left digit, and then I can make the register connected to the right one. So you see they can be independent of each other if you want. So that's what I am doing. So this one is controlling the enable and the segments for the right side, the right digit, and this one is controlling the left digit. So now let's write the code for all of these. So let's say right click, new Verilog source, and then let's call it main if I want. The main circuit. So you're supposed to do it by yourself here, but I will do it for you. Okay, so which means that I solved already the lab work for you. But because less experiment, like I'm seeing most of you have some difficulties with it. So I will do it here once as an example. So now, when you see the big circuit, you have to see how many inputs, how many outputs we have. So now, can anyone tell me how many inputs we have? الوقت شباب. Anyone? How many inputs يا عبد العزيز فهد?
Yes, 4 inputs.
Not 4.
5.
3.
5.
We have 5 inputs. 5 عدوها معي. We have a clock, we have a pulse, we have a clear, we have a load, we have the switches is here. Okay, so 5 of them. How many outputs we have?
4 outputs.
Only 4 outputs. So in general, if you work with the segment display, you will only have 4 outputs. The enable on the segments for the first digit and the enable on the segments for the second digit. So in total, we have 4 of them. Now, how many wires we have? Because that's a gate level, of course. How many wires we have?
3 wires.
3 wires. So you see, that's the first one here, and the second one here. And please keep in mind, this is a 4-bit wire. Don't make it a single bit. That's a 4-bit wire because the connection from here to here is a 4-bit. So that's a 4-bit wire. And then we have another wire here. That's another 4-bit wire. Be careful with that. So we know everything. Let's write the code for this one. Okay, so the inputs, I have the clock, the main clock. And then I have the clear button. And then I have the load button. That's for the register. We see it. And then I have the pulse button. That's connected to the counter. And then I have the switches. That is going to the register. So I think that's all the inputs. Now for the outputs, we have enable 1 and segments 1. And then we have enable 2 and then we have segments. Now we have to specify which one is input, which was an output. So input, I think all of them are input. So you just do copy and paste to make it easy. Copy and then paste. I think these are inputs. And also switches, don't forget. But switches is different because it's a 4-bit, because the register is a 4-bit for the input. So you say input 3 to 0. We have SW that's connected to the register. If you remember, this switches is 4-bit as an input, and all of them are single. Now let's go back, and then the outputs. For the output, I have a single bit. The enable and the enable are single bits. So enable 1, and then enable 2, semicolon. And then also the segments are the outputs because it's going to the 7-segment display, and they are 7 bits. So from 6 to 0. So we have these segments, and also we have the other segments. Inshallah كلكم معي. Semicolon. Yeah, there is no need, many spaces. And then for the wires itself. So now I have a single bit wire called W1. And then I have 2 wires that are 4 bits. So you have to write wire again as a 4-bit. W2, W3. خلاص. So now I will call the modules. So let's call the first one. So here, the first one, let's call it. We know this one is for the pulsar. So let's go back. And which one is the pulsar? This one. So I will copy its name and put it to the main project. That's pulsar, and then you say G1, and then you do some connections and then semicolon. Now for the connections, as I said before, can anyone tell me what's the order in general?
The same order.
The same
The same order. كان في بعضكم جدا ملخبطين. It's the same order. So you go back again and then you memorize the order. So we have first thing, the clock, and then the button, which is the input. So clock, the input, and then the output. So you go back, the clock itself, which is the main clock, and then the input, which is connected to the pulse, and then the output, which is connected to the wire 1. So you go back and then you write it here. So the first one is main clock, the same capital clock, the main one, and then the input is coming from the pulse button, and then the output is connected to the wire 1. That's it. We finished. Now let's go back to the diagram. We finished with this one. Now let's go to the other one. It's the counter module. So let's go back to the code. The counter module, we copy its name. And let's call it G2. And now the connections. So we say we have to follow the order. So let's go back to the counter. The order is the clock first, the input, and then the output. خلاص. The clock, input, output. So let's go back here. The clock, the main clock, the input is coming from the first wire. And then the output is going to the next wire. W2. I will call this W2. So clock, W1, W2. The main clock, W1, W2. Now we have here, we finish with this one. Now we have the hex 7-sig, the last one to translate the 4 bits into digits, into segments and enable. So we call this by its name. So which is it? This one. So we copy its name, copy, and then paste G3. Now the order. Let's go back, the order itself. So the order is what? We says X, which is input, and then the enable and the segments. X, enable, segments. Okay, so let's go back. So the input first, which is the wire 2, we call this wire 2. So wire 2, the enable, and then the segments. خلاص. We call this wire 2, the enable signal. So let's pick the enable 2 and then the segments 2. That's it. We finished with the first branch. Now the second branch. خلصنا من هذا اللي تحت. Now let's go above. So we have this register. Let's call by its name. So let's go back to the register, the first code. So we copy its name, register, and going to the main. Let's call it G4. And we have a bracket. So the order, so that's a big one. So the order is what? Clock, load, clear. Output, input. انتبهوا زين. Be careful. Clock, load, clear. So حبة حبة نمشي one by one. So the first thing is the clock. So I know it's the master clock. We know it. And then the next one, going back to the register, the next one is the load. So we know the load is connected to the load button. So I put the same name. Load is the same as the load button. So copying, pasting. Now the third one is the clear. So I know the clear is connected to the clear button itself. So it's very easy. It's connected to the clear button. Now the fourth one, if anyone has a question, ask me now. So now the fourth one, we have a Q, the output first. So let's go back. The Q is connected to what? To the wire, the new wire, W3. So I will say W3 first. Now the last one, it says D. So going back, D is connected to the switches directly. So it's the input switches. So where is SW? This one. SW, you paste it here. That's it. Now the last one, I take it باقي واحد. So that's the one. This one, Hex76. So I know its name. It's the same name, this one. You put it here. And then I will call it G5 because that's a new one. And now the connection. So I know it says X enable segments. So X is coming from the wire 3 and then enable and then segments. So you say W3 and then the enable 1 and then segments 1. Any questions so far? That's it. We finished. Any questions so far?
All clear, doctor, but what about the simulation?
I will do the simulation. I will tell you how to do it. Any other questions? تمام. هادي معي؟
ايه معك.
حسن المسلم؟
Hey.
حسان شويش؟ أو حسن؟
معك.
تمام. Okay, so let's continue on. خلاص قربنا نخلص. So let's do the compile first. Make sure everything works fine. Nothing is wrong. Now you have to select. Now I have, you see, I have all the modules here. So which one to simulate? Of course, the last one, because it will, I can test all of the others using the main one. So I will select it, the main one, and then I will do the simulation initialize. Now, what should we do? Okay, for the simulation, we have lots and lots of possibilities. So defining which one is like switches, counters, variable, you see, we have lots of options. So the first thing, you need to know what's going on to the circuit. So let's open the video. I have the video because we need to see in real life what's going on to the circuit. So please listen to me for the video. بالله عليكم اسمعوها زين، شوفوها زين. Yes, so that's the, you see, I already implemented and I took a video for it. So let's see what's going on. The project here, I already did that. So for the clear, I made it the first button. For the load, I made it the second button. And for the count up, I made it the third one here. And the switches is for the input D, like input switches for the register. So you see, I play with the input, but still nothing happens. Because you see, there is no load signal. Nothing happens. So initially, they both started with 0 initially. So if I want to write like 4 ones, let's say, so I made 4 ones here. So when I say load, هذا clear. load الزر الثاني. شو ما نضغط شو يصير؟ Second button, sorry, second button is the load. You see, it's F. I just switched the register for the right and the counter for the left. So you see, it's written. If I change it again, nothing happens because I didn't press the load. So let's write another value. Let's say 3, 0, 0, 1, 1. Let's load that value, 3. Let's format it. That's the clear button. If I did it, 0 again. Okay, so we confirm the register is working fine. يكفي, you see, that's enough. You confirm that the register is working fine. Write something to it, yes. Remove it, clear, yes. That's it. You confirm it's working fine. Now for the counter, I know the third button for the count up. So you see, when I press it only 1, it's 1. I press it again, 2, press it again, 3, and press it again. You see, it counts up only 1 time, you see? Nothing is wrong. It counts normally now. And I keep pressing it, but still it's 4. So when you keep pressing it, it doesn't count. You see, you have to remove and then press again. That's what we designed for. So you see, it only gives 1 pulse. So 5, 6, 7, 8, 9, A, because for the hexadecimal, B, C, D, E, F. Yes, Hamza?
Is there a way to make it count if you keep holding it?
Yes, there is a way in coding. Yes, there is a way. It will take some time. You can do it if you want. Okay, so let's continue on. Now the overflow issue, like I'm seeing 2 or 3 asking for the overflow. Now, if you count up again, what will happen? Now, when you have an overflow, it go back to 0. That's it. So that's the video. Now we understand. Okay, so now we have to understand what's going on. خلاص يا شباب, we understand. So now we need to do these things in simulation. طيب, we have to introduce something new in the simulation. Okay, it takes some time, but it's very easy, like if you understand what's going on. So we initialize the simulation. So how to do the same thing there? The first thing, I don't have the segments. I can't see the numbers. معي شباب ولا لا? I cannot see the numbers in segments. If it says 1, 1, 1, 0, I cannot see some number. So how to tell, like if the output is 0 ولا 1 ولا 2 ولا 3, how to tell? كيف أعرف إذا الجواب F ولا 0 ولا 1 ولا 2؟ كيف أعرف؟
It will show it in the waveform.
Yes, I show it in the waveform. No, because the output is segments, صح ولا لا? It will give me some codes for the segments. So
yes.
It will be hard for us to decode it back to the numbers. It will take some time. So how to know if the output is correct or not? Fast, like in a fast way. ركزوا شوية, واضح جدا.
If we try put some values.
No. If I see the output from the wires itself, شكلك ما انت فاهم السؤال زي الناس. So if I just see the wires only, that's the number we can understand, صح ولا لا?
Yes, we can present it in hexadecimal.
Yes, I can understand. If I see the wires itself before it converts to the segments, if I see the wire like 0, 1, 2, 3, 4, we can understand it's working fine. There is no need to see like the segments and then decode it back to see, yeah, it's supposed to be 1 or 2 or 3 or 4. So just see the wires itself. So go back to the, you see, only see the wires. Because I know the register output 4-bit, I know, I can understand it. No need to see after the coding. I cannot see it like, okay, you just see the wires. And then same thing for the counter. If you see only the bits, it's enough. These are just for the segments itself. Like if you see like 11101, you cannot understand. You have to decode it. طافي شغال, and then you convert it back to the numbers. It takes some time. But fastly, you can only see the wires itself. Okay. أول حركة, just see the wires. Wire 2 and wire 3. So let's see wire 3 for the register, wire 2 for the counter. Just understand. 3 for the register, 2 for the counter. Now, the first thing, you have to include all of them in the waveform طبعا. So right click, add to the waveform. The first thing, you do it. طيب. And then we're supposed to see stimulator and then add to waveform. I just reverse the options here. And it's supposed nothing wrong here, okay? Now, select all the inputs normally, and then you have to right click stimulator. Same thing, nothing new. Now let's see the time. First thing, the clock has to be 50 megahertz to match the one in the FPGA, because the FPGA, it has a clock 50 megahertz. So let's make the clock same thing, 50 megahertz. Now, for all of these, I can make them hotkey. Like if I press a button, it's like I'm pressing on the Elvis board. So I can make it hotkey. So let's say clear a hotkey. Let's say it's C. Apply. Load. I will make it a hotkey as an L. حمزة معي؟
Yes.
عبد الله الوهيبي معي؟
Yes.
مطلق؟
Yes.
فضل الله؟
Yes.
Yes.
Yes. Okay, so let's continue on. Pulse or hotkey P. So now these are the hotkeys in the keyboard. It's like I'm pressing the button. Now for the switches, there is no need to make it a hotkey, like it would take some time. So the easiest way for us to make it a certain value, only a fixed value. So let's say like 1010 for the letter A. So if I see A has been written to the register, I know it's working fine. So we don't care about the value, just put any other value. So let's make it A for the switches. Now we are set. That's it, we are set. So you make sure you pressed here like one time to enable the thing. Now let's see if I press like the clear button. So I'm pressing C now. What does it say below here? You know what's, yeah, so I can toggle it between 1 and 0. So now I can make it clear 1. I will make clear 1. So you see, it's not exactly real life, like you just see and then pressing and you know what's going on. You cannot do it. You just do it step by step. You prepare the buttons. Okay, this one is pressed. This one is not pressed. This one is pressed. And then you run it for a certain amount of time and then see what's going on. And then you change the status. Okay, this one is pressed. This one is not pressed. This one, you see, we do like this. So I will make the clear pressed. So now the clear is 1. Now I will make the pulse 0. I don't want to press it now. I want to test one by one. And let's make the load also 0. So nothing there. The load is 0, pulse is 0, clear is 1. So now we have to run for a certain amount of time. How to do it? You say run for. If you remember, run until the old time, and then you can say run for. So you can do it by here, or there's a shortcut here. So you see, that's the same thing, run for. Don't play with it. Let's leave it 100 seconds. So let's say run for, and let's see what's going on. الكلير شغال. So we're supposed to see the register has a 0 on it because we format it. نعم.
When we press clear and pulse and load, will that be the initial value for them?
Yeah, the initial value.
Yes, or it will be at the red line.
At the red line? No. The red line, ignore it, okay? Ignore it.
So what we pressed is the initial value for it.
Yes, the values. Okay, the load is 0. So let's make sure the load is 0, the pulse is 0, and the clear make it 1. So now I'm pressing on the clear. خلاص؟ تمام. So when you run for, شوف ايش راح يطلع معك في الصورة. Now let's see what's going on. Now, don't be afraid. It's very easy to understand. Now we see the clocks is running. That's the clock is running. And now let's see the switches. Of course, it's fixed as an A. We did it there. And now see the clear button is pressed. You see all are 1, and the load and the pulse are 0s because I made them 0. Now let's see we say the W3, I think W2 or W3, but both of them are 0s. You see, I cleared the memory. One of them for the counter and the other for the memory. You see, it's 0 because I cleared it. I say clear. So now both of them are 0s. It's working fine. The clear button works. So now I will change the state. Make sure you pressed something there. And now I will make load 1. So I will press L. The load is 1. I will turn off the clear. So I'll say C. I turned off the clear. Now. So now load is enabled. Of course, it's not happening here, so I have to run 4 again. So what's going on? So now see the register W3, that's the output for the register. It says A because I pressed the load. فهمت عليه ولا لا? It's steps by step. You prepare the buttons and then you say run 4. So now after I press the button, the next positive edge, the load اشتغل. Now see the load is A. So the memory has been written by A. تمام. Now I will remove the load L and run again. Of course, it should be the same value. A. Nothing happens. Even if you change the switches, it's supposed to be the same thing. Now I can make it clear again to test it. So I'll say I will turn off the load and then make a clear signal. Clear is 1. Run 4 is supposed to be 0. So now you see that W3 is 0. So now I tested the register. It's working fine. Any questions so far? Any questions?
What is 7A on segment 1 and 2?
That's the translation of the number 0. If you convert it back, تخيل انها لمبات A, B, C, D, E, F, G as a binary, you will know it should represent number 0. So let's go radix binary, radix binary. So ما قلنا الرقم 0 كل شيء شغال الا اللي في الجي 0 صح ولا لا؟
Yes, doctor.
Okay, just like the hexa equivalent of it. So now it's working fine. خلاص, we tested the register. Any other question before we move to the counter? تمام. So let's I think let's turn off this clear signal. Let's turn off the load signal. Okay, so the register now everything is off. Now let's do the pulse. So now I will make the pulse 1. So it should count up now. I am pressing the pulse. So let's say run, where's run 4? Yeah, run 4. Now let's see for the pulse here. So that's the output. W2 is the output for the counter. Now it's going to 1. وشوف متى ضغطت الزر البulse هذا شوف it's 1. So you see it missed some because you know the delays, these stuffs, but now the W2 is 1. It counted up by 1. والشاشة حقه سيجمس تغيرت صارت هذا الرقم. You see 0 1 1. That's number 1. So it's working fine. Now the button is pressed. If I run it again, run 4, it's supposed to be the same thing, 1, because you have to remove it and press it again. We say that you have to remove and press again to count up again. So now I will remove it, pulse 0, you have to run because it has to register that you have removed the button. And then you press again, pulse is 1, you do the run 4, now it says 2. And so on. You have to remove. Run 4, press, run 4, and now it's 3, and so on. You have to continue all the way. Okay, I cannot do it here because it would take some time. So pulse is 1, pulse is 0, pulse is 1, وهكذا. Now it's 5. You see, it's counting up. And then you reach to the last value, which is F, 15. And then if you count up again, it's supposed to go back to the 0. And you confirm that the counter is working fine. And we see like initially it should work fine. So now how to submit your work? Of course, you do the same thing. I did all of these here. So you write the code for all of these, and then you do the main code, and then you do the simulation, and then you start doing the testing. You press the buttons and do all the testing. Make sure everything works fine. Now, how to submit the waveform? You see, whereas the other testing, it doesn't miss. So how to take the full test? You say right click here. انتبهوا معي شباب. Right click after you do all the testing. Right click, zoom to fit. Because it's already there. So you say zoom to fit. Now let's see all the tests that you have done so far. It's there. So you see the clear signal 1 is 0. Now the clear signal is off and the load signal is on. Now we have written A. Now the load signal is off and the clear signal is on. It's 0 all the time. And then let's see the counter. So you press the button, the pulse button. You press the pulse button. and now you see the wire 1 اللي جايه من البلسر, it gives 1 pulse, and then it counts up 1, and then you press again the 1 button, it gives a pulse, and then we have the number 2, you press again, that's the pulse, and number 3, and so on, number 4, 5, 6, 7, 8, 9, 10, up to 15. And then you take a screenshot of the waveform, including the screenshot of all the codes, and then you submit it to me. That's it, the report. Any questions so far?
Doctor, do we need to test all the values?
Yes, all the values for the counter, and all the values for the register. You have to test the clear, the load. Any questions so far? You see, I have given you the answer. No questions?
Doctor.
نعم.
Will we implement it in the FPGA?
No, خلاص راحت المحاضرة. Okay, it's a simulation online today.
Okay.
I already did that. I showed you what's the expected result.
Yeah.
Any other question?
Doctor?
Yes?
Can I ask about something in the code?
Yes, what about it?
Yeah, the last one, the main
Yes.
one, yeah. Can I know why you use wire instead of rig?
Yes, that's a gate level.
Oh, okay.
That's a gate level, you use wire. It's not gate level always, you use rig. فهمت علي؟
Thank you. Yes, yes.
تمام. Any other
Thank you.
questions؟ خلاص يا شباب يعطيكم العافية. يعطيكم العافية يا شباب. خلاص you can leave. So let's stop the recording. Any questions you can ask